So, we're talking about sequences first in this unit. So, a sequence is like a list of numbers, and they can go on forever. And then later in the unit, we'll talk about a series which has like a finite number. So, maybe just 10 terms or something. But a sequence has an unlimited and infinite amount of terms. So, we're looking at two different kinds. We're looking at arithmetic and geometric. So, an arithmetic sequence arithmetic sequences have a common, write this down, difference. So when you think about the word difference, what operation comes to mind if you want the difference of two numbers? Subtraction. So an arithmetic sequence is when you are adding or subtracting. And then our other one is a geometric. So geometric sequences have a common ratio. So what operation do you think about when you think about ratio? Division. So a geometric sequence is multiplying. Okay. But it does not include dividing. So division turns into multiplying by a fraction. Bless you. So if you have, like, the pattern is you're dividing by 3, that's the same thing as multiplying by 1/3. Okay? So for adding and subtracting, it really doesn't matter because subtracting is just adding a negative, so it's the same thing. But for multiplying, you have to change that. If it's division, you have to change it into multiplying a fraction. Okay, so geometric is just multiplying. It's not dividing. So, first thing we want to do is find the next two terms. And decide if it's arithmetic or geometric. So our first one is 1, 4, 7, 10, etc. So what's happening each time? So to get from 1 to 4, we add 3. 4 to 7, we add 3. 7 to 10, we add 3. So what would be my next two terms? Good. 13 and 16. Good. So if we're adding 3, does that make it arithmetic or geometric? Arithmetic. Good. And so then we would say that our common difference is 3, because that's what we're adding each time. Questions? Alright, let's say we have this one. 4, 12, 36, etc. So what's happening each time? We're multiplying by 3. So then what would be the next two terms? Good, 108 and 324. Good. So all you do is you got times 3, so you just do 36 times 3. 108 times 3 is 324. So arithmetic or geometric? Good, geometric, because we're multiplying. So then we would say the common ratio is 3. Questions? Alright, one more. What if we have 28, 14, 7, 7 halves, etc.? So what's happening each time on this one? So it's dividing by 2, but remember we don't want to divide, we want to multiply. So dividing by 2 is the same thing as multiplying by 1/2. Now it's not always going to be like a nice fraction, so if you're ever unsure, what you can do is do the second term divided by the first term. So 14 divided by 28 gives me 1/2. And then you can just make sure that that's true. So 14 times 1/2 is 7. 7 times 1/2 is 7 halves, etc. Okay, so that's how you find it if you're unsure. So 14 divided by. So second term divided by the first term. So then what would be my next term? Yeah, 7/4, and then 7/8. And again, you can just type those in your calculator. 7 halves times 1/2 is 7/4, and then you can just keep on going. Good. So arithmetic or geometric? Good. Geometric. Any questions on those? Alrighty. So next, sometimes they'll give you a formula. So we're going to use the formula to find the first 3 terms. And decide if it's arithmetic, geometric, or neither. So our first one is a sub n equals 4n minus 7. So in these problems, it's all about terms. What term are you looking for? What term do you know? So the n represents the term. So if I wanted to find the first term, I do a sub 1. So that doesn't mean a times 1. That means a sub 1. So that means the first term. So a sub 1 stands for the first term. And then to find it, we plug 1 in for the n. So 4 times 1 minus 7. And what does that give me? Negative 3. Good. So then my first term is negative 3. Okay. So then if we want the second term, a sub 2, we just plug in 2. So 4 times 2 minus 7. And what is that? 1. Good. So then the second term would be 1. And then we want the third term, so a sub 3, 4 times 3 minus 7 is what? Good. 5. So we've got negative 3, 1, and 5. So what's happening each time? So it's adding 4 each time. Good. So is it arithmetic or geometric? Good. Any questions on that? Alright, let's look at this one. So let's say we have a sub n equals 2 times 5 to the n power. So we want the first term, so we do a sub 1, 2 times 5 to the 1. So what would that be? 10. Good. So 5 to the first power is 5, and 5 times 2 is 10. So then for our second term, 2 times 5 to the second power is what? 50. Good. And then we also want the third term. So 2 times 5 to the third. Which is what? 250. So what's happening each time? It's multiplying by 5, which means it is good, geometric. Good. Questions? All right, so we got one more. So let's say we have a sub n equals 2 over n. So again, we want our first 3 terms. So a sub 1 would just be 2 divided by 1, which is what? 2. Good. So then we want the second term, so a sub 2. So 2 divided by 2 is what? So then our last term, a sub 3, 2 divided by 3, yeah, that's a repeating decimal, so we can just leave it 2/3. So what's happening each time? Is there a pattern? I mean, there's a pattern because it's 2 over 3, but it's not adding, subtracting, or multiplying. So this one would be neither. Okay. So you can still find the first 3 terms because you just plug 1, 2, and 3, but that doesn't necessarily mean it's going to be arithmetic or geometric. So let's look back at number 1. So if we look at number 1, we had 4n minus 7. What kind of equation does that look like what we were doing yesterday? A linear. And it was arithmetic. Well, if we look at geometric, this 2, 5 to the n power, what does that one look like? Exponential. So an arithmetic always follows a linear pattern. A geometric always follows an exponential pattern. Okay. Questions?